Hey guys, so we are going to be getting started with week 4 for our distance learning. This week we are going to be solving polynomial equations, whether they're in factored form or whether we have to factor them first. Okay, and it's really important to know this property. It is called the zero product property. Okay, and that's how we are able to solve polynomials, especially quadratic polynomials that we're talking about today. So if AB is equal to 0, A times B is equal to 0, then A is equal to 0 or B is equal to 0. Sounds a little confusing, doesn't really seem like it would make any sense, but once we get into actually solving some of these problems, I think it will really help. So if you look at the directions here, solving polynomials in factored form, we're going to set each parenthesis equal to 0 and then solve for x. Those are going to be all of our possible solutions. So if we start with number 1, I'm going to take everything and set it equal to 0. So 4, I'm setting that equal to 0. The only issue is here, that just doesn't make sense, right? 4 can't equal 0. So if you ever just have a constant out there, you can ignore it for this. Then you're going to take x minus 3 and set that equal to 0. You're also going to take x plus 2 and set that equal to 0. And then the next step is to solve for x. Okay, that's the next thing you want to do. So here we're going to add 3 to both sides. So x is equal to 3, subtract 2, x is equal to negative 2. So my answers would be x is equal to 3 comma negative 2. It could be either one of those options. And what that means is, because a solution to a quadratic equation is whenever you get it to equal 0. So if I put 3 back in to my equation for x, 3 minus 3 is 0. 0 times anything is going to give me 0. I know I did it right. Okay, so those are what our solutions are. They would give us 0 if we plugged them back in. That's why we're setting them equal to 0, because we want to know, when will my quadratic equation be equal to 0? Let's look over here at number 2. So in number 2, you have x plus 5 all being squared. Okay, instead of foiling that out and then having to refactor, because that wouldn't make sense, what you're just going to do is split this up and write it as x plus 5 times x plus 5. And that's equal to 0. Set both of those separately now equal to 0. X plus 5 is equal to 0. X plus 5 is equal to 0. And then solve for x. Subtract 5 from both sides. X is equal to negative 5 and x is equal to negative 5. So our solutions would be negative 5 and negative 5. Okay, so in this case, negative 5 is the only number that would get us a solution for this polynomial. Okay, let's look over here at number 3. Now I'm still setting everything equal to 0. So I have 3x, I'm setting that equal to 0. X minus 1, setting that equal to 0, and x plus 8, setting that equal to 0. 3x is equal to 0 was not the same as what we had up here with 4 equals 0. If there's an x, you can solve it. I can divide both sides by 3, and I get x to equal 0. Over here, I can add 1 to both sides, so x is equal to 1. Over here, I can subtract by 8, so x is equal to negative 8. So my answers would be x is equal to 0, comma 1, comma negative 8. Any of those options would work as a solution to this quadratic equation. In this case, it actually wouldn't be a quadratic. To this polynomial, I'll say. Okay. And number 4. Again, setting all 3 of these equal to 0. So 2x plus 1 is equal to 0. 3x minus 2 is equal to 0. X minus 1 is equal to 0. I'll first subtract 1 from both sides, so 2x is equal to negative 1. Divide by 2, so x is equal to negative 1/2. Over here, I'll add 2 to both sides. 3x is equal to 2. Divide both sides by 3, so x is equal to 2/3. Lastly, I'll add 1 to both sides, so x is equal to 1. So my solutions are negative 1/2, 2/3, or 1. Any of those, if you plug them into the equation, would be a solution because they would give you 0. So those were nice because those problems were already all factored for us. Now, what happens if they're not already factored and we have to do that first? So that's the second thing we're going to focus on. So we're going to factor a polynomial equation and then find the solution. So what if the polynomial is not in factored form? How do we solve it? We first get all of the terms on the same side of the equation. Okay, that's the first step. So we want to set the equation equal to 0. So if we look over here in this example, the first thing I'm going to do is bring that negative 7x squared to the other side. So I'm going to add it to both sides. So now I have x to the third plus 7x squared minus 8x is equal to 0. You always want it to be equal to 0. Step 2 then says factor out a GCF if possible. If not, factor the trinomial or 4-term polynomial. So let's see if there's a GCF that I can take out. I can take out an x from here. So then I'd be left with x squared plus 7x minus 8. That's equal to 0. And then I still need to go ahead and factor the trinomial. That's what I have left in my parentheses for this one. So you leave that x out there. What multiplies to negative 8? So what multiplies to negative 8? That adds to 7. You have positive 8 and negative 1. So x plus 8 times x minus 1 is equal to 0. And then the last step is to set each factor equal to 0 and solve for x. So I set x equal to 0, x plus 8 equal to 0, and x minus 1 equal to 0. And we would end up with 0, negative 8, and 1 as our answers. Okay, so it's just combining what we just did up above with what we've been doing before. Okay, so now we're going to solve each of these polynomials by factoring. So you first always want to look for a GCF to make your life a little easier. So here I can factor out a 3x. So when I do that, I'd be left with x minus 3, right? 3x squared divided by 3x is just going to leave me with x. 9x divided by 3x is just going to leave me with 3. Set that equal to 0. Now set both of those separately equal to 0. So we're going to have 3x is equal to 0. X minus 3 is equal to 0. Divide both sides by 3. So x is equal to 0. Add 3 to both sides. So x is equal to 3. So my solution would be x is equal to 0 or 3. Okay? So just a little bit of extra work. And number 2, first thing we have to do is get everything on one side. I know it looks like it would be easier to just bring the negative x squared, but then you'd have to remember to factor out a negative. And if you feel like you'll remember that, that's totally fine. For me, I'd rather bring everything over to the right-hand side, to the left-hand side. Sorry, it just makes more sense for me that way. So I'm first going to combine the negative 10x and the negative x to become negative 11x minus 10. So then I'm going to add 11x to both sides. And I'm going to add 10 to both sides. So now I'm going to have x squared plus 11x plus 10 is equal to 0. I have a trinomial, so I can factor it. So that's the same as x plus 10 times x plus 1. Set that equal to 0. Again, we were figuring out what multiplied to 10 added to 11. So now I can individually set those equal to 0. X plus 10 is equal to 0. X plus 1 is equal to 0. Subtract 10 from both sides, x is equal to negative 10. Subtract 1 from both sides, x is equal to negative 1. So x is equal to negative 10 or negative 1 would be my final answer. Okay. Number 3, same thing. Have to get everything to one side. So I'm going to subtract x squared and subtract 3x. So I'd be left with x squared minus 2x minus 48. I'm just putting that in standard form. Okay, and then I can factor. I can figure out what multiplies to negative 48 that adds to negative 2. That would be negative 8 and positive 6. So then it would be x minus 8 times x plus 6 is equal to 0. Set both of those separately equal to 0. X minus 8 equal to 0. X plus 6 is equal to 0. And then solve for x. Add 8 to both sides, so x is equal to 8. Subtract 6 from both sides. or x is equal to -6. So my solutions, 8 or -6. Either one of those would work. Number 4, so over here, I'm going to bring the -3x to the third over to this side. So I have -3x to the third plus 6x squared minus 3x. Again, just putting that in standard form. I can take out a GCF here of -3x. So when I do that, I'm left with x squared minus 2x plus 1, and that's equal to 0. And again, the reason why I took the negative out is I don't want my x squared to be negative. So now I have a trinomial that I can factor, so the -3x stays out front. What multiplies to +1 that adds to -2? That's -1 and -1. So x minus 1 times x minus 1 is equal to 0. And then set all of those separately equal to 0. -3x is equal to 0. X minus 1 is equal to 0. X minus 1 is equal to 0. Then we solve for x. Divide by -3. So x is equal to 0. Add 1. X is equal to 1. Add 1. X is equal to 1. So my solutions, x is equal to 0, 1, or 1. Okay, so that was with factoring. Now we're going to look at a couple problems with grouping. Okay, so in number 5, and what I actually want us to do, I want us to go ahead and get some practice doing a part of this on our own. So for numbers, I'm going to do 5 and 6 with you, and then 7 and 8, I'm going to have you pause the video and then resume it again and check your work against mine. Okay, so let's do 5 and 6 together first. So I'm first going to go ahead and group. So I can factor out an x squared, and I'd be left with x minus 1. Over here, I can factor out a -16, and I'd be left with x minus 1. So then I have x minus 1 times x squared minus 16 is equal to 0. But here I actually have, and hopefully you recognize this, a dots problem. So this can factor to be x minus 1 times x minus 4 times x plus 4. I can factor that even more. So now I can set all three of those equal to 0. X minus 1 is equal to 0, x minus 4 is equal to 0, and x plus 4 is equal to 0. Then I can solve for x. Add 1, x is equal to 1. Add 4 to both sides, x is equal to 4. Subtract 4 from both sides, x is equal to -4. So my answers for this one would be 1, 4, or -4. Okay? Number 6, everything thankfully is already set equal to 0, so that's one less step that I have to worry about. So then I can just go right ahead and group. So in this first part, I can take out, what can I take out? I can take out an x squared, and I'd be left with 2x plus 7. In the second one, I can take out a -100, and I would be left with 2x plus 7. So then I would factor out my 2x plus 7, and I'd be left with x squared minus 100. Pay attention, though, again, because this is another dots problem. So 0 is equal to 2x plus 7 times x plus 10 times x minus 10. And then I can set all of those equal to 0 separately. So 2x plus 7 is equal to 0, x plus 10 is equal to 0, x minus 10 is equal to 0. And then I can solve. So I subtract 7 from both sides. 2x is equal to -7. Divide by 2. So x is equal to -7 halves. Subtract 10 from both sides. X is equal to -10. Add 10 to both sides. So x is equal to +10. So my answer here would be x is equal to -7 halves, -10, and 10. Okay, so for number 7 and 8, first make sure you are getting 0. You're getting everything set to one side so that it's all equal to 0. And then I want you guys to go ahead and try these on your own, and you're going to check my answers in just a minute. Okay, so here is the work for number 7 and 8. If I were you, I'd probably pause this at some point to be able to actually look through my work and check to make sure that you did everything that I did as well. But this is the work for them. In numbers 7 and 8, you ended up with a dots problem again, so just make sure you are handling that. And if you have any questions, you can just ask me during our live session. So I'll see you guys soon.